Hello friends, today we'll be starting our first mathematics lecture and I'll be teaching complex number. In the previous lecture I told you, in the previous video I should not say lecture, in the previous video I told you about the course outline or the chapter outline to be more precise, how I'll be, in what order I'll be uh, going along teaching complex numbers. This is the first lecture and I'll be starting with arc and plane. Okay, so you might have heard about Cartesian plane. So Cartesian plane contains points in the form of coordinates, okay, x and y. Similarly, we have argand plane. Argand plane is the plane that contains complex numbers. So it's basically the same thing. If you are comfortable with Cartesian plane, if you are able to draw the points on the Cartesian plane, you will understand argand plane in no time. It's exactly the same thing, just a very just a different notation that we use in the argand plane. So complex number we generally represent by the letter z. Okay, so any complex number can be written as a plus ib. Now in such a if you have such a complex number, a represents real part of complex number, okay, and b represents imaginary part. And how to understand, how to identify what is the imaginary part? Simply the part, the component that is connected with the I. This I means iota. Okay, and mathematically speaking, I is nothing but square root of minus 1. So that we have I square is equal to minus 1. Gradually, slowly, you will begin to understand and appreciate the importance of complex number. As of now, just take these values at face value, okay, and gradually as you will understand, you will start appreciating the concept. So I represents iota, and whatever part is connected with I or the iota is known as the imaginary part. Now let me come to the argand plane. So similar to the Cartesian plane, we have the argand plane. This is known as the real axis. Real axis. The y-axis is known as the imaginary axis. Okay, so if you have any complex number that is equal to a plus ib, the real part a is represented on the real axis. The imaginary part, the part connected with iota, is represented on the imaginary axis. Okay, very simple. So suppose this is the origin. This will be 1 2 3 4 5, so on and so forth, minus 1 minus 2 minus 3 minus 4 and so on and so forth. 1 2 3 minus 1 minus 2 minus 3. So you can represent the complex number. Suppose I take the example z is equal to 1 plus I. So the real part is 1, the imaginary part is also 1. Okay, so the real part is 1, the imaginary part is 1. So this is the point. So the complex number z will be nothing but a straight line joining origin with the point 1 comma 1. This will be the complex number z. Okay, so let us call it this as z1. Let me take another example. Z2 is equal to minus 2. Suppose I say minus 2. Now you must be thinking, where's the imaginary part? There is an imaginary part. How? If I write it as plus I into 0. So the imaginary part is 0. The real part is minus 2. So the real part is -2, imaginary part is 0, so this is the point. And so this will be Z2. Okay, so I can say any purely real number in which pure real number is in which imaginary part is 0 lies on the real axis. Okay, and similarly any pure imaginary number in which real part is equal to 0 lies on the imaginary axis. Okay, very simple. So let me draw the argand plane once again. If suppose the complex number is 5i, now the real part I can write it as 5i plus 0. So the real part of z is 0, the imaginary part of z is 5. Suppose this is the point, so this will be the complex number. This will be the complex number z. Okay, so all purely imaginary number lies on the imaginary axis, all purely real number lies on the real axis. So this is the basic representation of complex number on the argand plane. So it's very similar to the vectors. If you remember, the vectors we also used to represent vectors in similar way. Okay, if there is any vector, suppose 2i plus 3j, let's say any vector a, then what you used to do, you used to plot 2 on the x-axis and 3 on the y-axis. So this was the vector. Same thing as here z. You are plotting 0 on the x-axis and 5 on the y-axis. So complex number are, if you are very comfortable with vectors, once again you will be very comfortable with the complex number. You will learn complex number in no time. Okay, the operations are also very similar. Just if I take the example, suppose I have a vector a and another vector b, like this is vector a and this is another vector b, and if I ask you what is a plus b, then what we do is that we translate either a or b. Suppose we are translating a, then we'll keep the head of a on the tail of b. Okay, so this is b. I'll translate the vector parallel to itself and keep its head on the tail of b, and now we will complete the triangle. Okay, and in this line that we are getting, the head will coincide with the head and the tail will coincide with the tail. So this line will represent the vector a plus b. Okay, same is with the complex numbers. So if you have a complex number, say z1, and you have another complex number, say z2, okay, and you are required to find z1 plus z2, then what you do is you simply translate z2 and keep it on the head of z1. The resultant will be the sum of the two complex numbers. Okay, so the operations are very similar. We'll go into detail, don't worry. This is just the introductory lecture, and I hope you have a very basic idea of what argand plane is. Okay, in the next video lecture we'll move forward with some new topic. Okay, so stay tuned and let's meet in the next video lecture. Thank you.